Okay, I'm just going to run through some of these examples for people who are really struggling with balancing equations. The first three are the three out of the compendium that we've already done, so I'll start with the fourth one. So looking at this, it's good to use erasable ink or a pen with a rubber because you end up rubbing stuff out and changing numbers a bit when you're balancing equations. So I've got phosphorus and bromine. They're both on their own on the left-hand side, so it doesn't matter too much which one I start with. So I'll just start with phosphorus. So I've got 4 phosphoruses on the left-hand side and only 1 on the right-hand side, so I need 4 on the right-hand side. Now I have 20 bromines on the right-hand side, so that's 5 lots of 4 is 20. So I need 20 on the left-hand side, but I only have 2. To make that 20, I need 10 of those. The next one looks fairly complicated, which is upsetting. So it just doesn't really matter what I pick to start with. I'm just going to go with something that looks fun. I'm going to go with sodium. I think it might be easier to start with sodium because it's only in 2 compounds rather than several. So let's go sodium. So on the right-hand side I have 3 sodiums, which means I'll need 3 on the left-hand side. So I need 3 lots of sodium hydroxide there. Now I need to check the other numbers. So let's look at oxygen. I've got 4 oxygens there, plus 3 there, which is 7. And here I've got 4 plus only 1. So if I want 7, the easiest way to get 7 is going to be to have 3 waters. So I now have 7 oxygens on each side. At this stage, we check phosphorus and we check hydrogen and we sort of just pray that they're equal. Otherwise, it's a really complicated one. So on the left-hand side, I've got 3 hydrogens here plus 3 here, so 6. On the right-hand side, I've got 3 lots of 2, so 6. And for phosphorus, I've got 1 phosphorus on the left-hand side, 1 phosphorus on the right-hand side, so everything is balanced, so that's good. Next one, so let's just start with nitrogen. 2 nitrogens on the left, so I'm going to need 2 on the right, so I'm going to need to double that. So now on the left I've got 2 hydrogens and on the right I've got 6 hydrogens. So 2 lots of 3 is 6, so I need to triple the hydrogen gas on the left-hand side. The next one, I'm going to leave oxygen until last because it's the only thing here that appears by itself. Hydrogen and nitrogen look more complex, so I'll start with one of those. I'm just going to start with nitrogen. I've got 1 nitrogen on the left and 1 nitrogen on the right, so at the moment that's okay. Hydrogen, I've got 3 hydrogens on the left and 2 hydrogens on the right, so I'm going to need to double the first one and triple the other one so that I have 6 hydrogens on both sides. Now that I've done that, it's changed the nitrogen. So I now have 2 nitrogens on the left and only 1 on the right. So I need to double the nitrogen dioxide on the right. So I have the same number of nitrogens on both sides. Now all I have left is oxygen. So let's have a look how many oxygens I have. So I have got 4 here plus 3. So I've got 7 on the right-hand side. So on the left-hand side, I need half of 7. So that would be 3.5, wouldn't it? But we don't like decimals as coefficients. We need whole numbers. So I'm going to go through and double all of the coefficients there to make it nicer. So there's going to be 4 of those, 7 of those, 4 of those, and 6 of those. Okay, the next one is similar to question 3, which we did, so you guys might be fine with this without me. I'm going to leave oxygen till last because it's the only one that appears on its own again. So I'm going to start with either carbon or hydrogen. It's going to go with carbon. 6 carbons on the left, so I want 6 carbons on the right. So I'm going to need 6 lots of carbon dioxide. Now I'm going to do hydrogen. 6 hydrogens on the left, and I've got only 2 on the right. I'm going to need to triple the amount of water so that I have 6 hydrogens on the right. Now I'm going to do oxygen. So here I have 12 oxygens, and here I've got 3, so that's a total of 15 oxygens. Whatever I put out the front here is going to be doubled because it's O2, so I need half of 15, which is 7.5. And we end up with a decimal again, so I'm going to double everything again. So 2 of those, 15 of those, 12 of those, and 6 of those. Okay, the next one looks like not my favourite one ever. I'm going to leave copper till last because it's by itself. The messiest one looks like maybe oxygen, but I would do oxygen, hydrogen or nitrogen first, I suppose. It doesn't really matter which one you do, you might end up changing things. I'm going to do hydrogen first just because it's the first one that appears, but I might end up changing the numbers here because it looks kind of like a nasty one. Let's see what happens, hey? All right. So I've got 2 hydrogens on the right hand side, so I'm going to put 2 on the left hand side. Now, nitrogens. I've got 2 nitrogens on the left hand side, but I have got 3 nitrogens on the right hand side. So that's not my favourite. So I'm going to need more nitrogens on the left hand side, but without ruining the hydrogens. So this is quite a difficult one. You're unlikely to get one like this in this course. This is probably more advanced than physical sciences needs to be. But what I'm going to do is I'm going to double that to 4 so that I can put a 2 out the front of there. I'm hoping that even numbers are sort of going to work for me. So now I've got 4 nitrogens on both sides, and I've got 4 hydrogens here, so I'm going to put a 2 there to get 4 hydrogens there. So the reason I went with 4 here is because if I went with 3, then I wouldn't be able to get 3 hydrogens over here because putting a number out the front is going to it's going to be 2 lots of the number of hydrogens because there's a 2 next to the H. This is a bit confusing probably, sorry. Now that I've done hydrogen and nitrogen, I need to check the others. Copper still looks okay. Let's check out oxygen. So on the left-hand side, I've got 4 lots of 3 oxygens, which is 12. On the right-hand side, I've got 6 here, plus 4 here, plus 2 here, which is 12. So I've got 12 oxygens on each side, so that one is balanced. Okay, next one looks nice and straightforward because both magnesium and chlorine are on their own, and looking at it, it's already balanced. So we can just leave that one. The next one, chlorine and oxygen, again, they're just on their own on the left-hand side, so that shouldn't be too tricky. Chlorine's already balanced. I've got 2 oxygens on the left-hand side and 7 oxygens on the right-hand side. So I can't times something by 2 to get 7, unless it's 3.5, which we're not going to do. So I'm going to chuck 7 out there and 2 there. Swap them. Okay, because now I have 14 oxygens on both sides. So I now have 4 chlorines on the right-hand side, so I need to double that. So I have 4 chlorines on that side as well. Next one. Okay, let's balance barium, or barium. Everybody gets cross when I pronounce it barium, sorry. So 3 bariums on the right-hand side, so let's chuck 3 on the left-hand side, and nitrogen is already balanced. Next one. All right, carbon's on its own and iron is on its own, so I'm going to leave those till last and balance oxygen first. So I've got 3 on the left-hand side, 2 on the right-hand side, so I need 3 here and 2 here, so that I have 6 on both sides. Now I'm going to balance iron, I suppose. I've got 6 on the left-hand side, so I need 6 on the right-hand side. Carbon, I've got 1 on the left-hand side and 2 on the right-hand side, so I'm just going to double the left-hand side, and that one's done. Okay, next one. Here we've got oxygen on its own, so I'm going to leave oxygen until last. So I'm going to do lead or nitrogen first. Lead already looks balanced, just looking at that. So I'm going to move to nitrogen. On the left-hand side, I've got 2 nitrogens because I've got 2 lots of nitrate, and in each nitrate there's 1 nitrogen. So 2 nitrogens. On the right-hand side, there's 1 nitrogen, so I need to double the number of nitrogens there. Now I've balanced lead, I've balanced nitrogen. The only one left is oxygen. So let's have a look. I've got 6 oxygens on the left-hand side. And on the right-hand side, I've got 2, another 4 here. So 6, 7. I've got 7. I hate that. And I want 6. So what we do is we just cross out that oxygen like so. It's a small joke. We can't do that. Sorry. Okay, now this is a super complex one. I don't really want to do this one if I'm honest. So what do I do? How do I do this? Let me think. Oh, I feel like I want to double this and see what happens. If I double that, I have to double this, don't I? Now let's check things again. I just think even numbers often work out better, and because there's only 1 oxygen in lead oxide, I'm like, oh, that 1 is causing me problems, so I'm going to make it an even number, so I've doubled it. We'll just sort of balance things then and see what happens. So I now have 2 leads on both sides. Nitrogen, I now have 4 nitrogens on the left-hand side, don't I? So I'm going to change this to a 4 to balance nitrogen. Now I'm going to check oxygen again, and I'm crossing my fingers and just hoping that it works, because if it doesn't, then it's really complex and I hate it. So oxygen on the left-hand side, here we've got 6 times 2 is 12. On the right-hand side, I've got 2 plus 8 plus 2, which makes 12. But luckily, that's the right answer. Okay, so that's fantastic. That was kind of gross. Sorry. Next is another combustion reaction. So it's another one of these, and also the same as part 3. So leave oxygen till last, do carbon and hydrogen first. So number of carbons is 6, so I need 6 there. Number of hydrogens is 14 on the left, so I'm going to need 7 on the right. Number of oxygens on the right is 6 plus 7, which makes 13. So I need half of 13 here, which is 6.5, obviously. Again, decimal, we hate that. Let's double everything. So 2, 13, 12, 14 for that one. Ugh, the next one looks like not my favourite one that I've ever seen. I'm going to balance hydrogen first, because hydrogen's only in 2 of the compounds, 1 on the left and 1 on the right. So on the left I've got 12, on the right I've got 6, but if I double that, then I end up with 12 on both sides. Hydrogen is what I just did. Carbon, I've got 6 on the left and 5 on the right. So I've got 4 here and 1 there. If I double that, I'm going to have 4 and 2 is 6. Now I again cross my fingers and hope that I've got 6 oxygens, which I do, because I've got 2 here and 4 here. Okay. Good. Next. All right. I'm going to do phosphorus first, just because it's the first one that I see. I'd leave oxygen till last here because it's in all of them. So it might be sort of hard to do first, but yeah, it's hard to know which one to do first in this kind of situation. You just got to pick one and try it. So 4 phosphoruses on the left-hand side, so on the right-hand side I'm going to need 4 of those. Now I have, what shall I do now? Hydrogen? Let's do hydrogen and just hope that oxygen works by itself. So on the left-hand side I've got 2 hydrogens, and on the right-hand side I've got 4 lots of 3 hydrogens. 4 threes are 12. So to make this 12 I need 6 there. So I've got, now looking at oxygen, 12 oxygens on the left-hand side, and hooray, 12 oxygens on the right-hand side because it's 4 lots of 3. Next, I'm going to do hydrogen first because it only appears in 2 of those. Hydrogen's balanced, so that's fine, whatever. Oxygen, 2 on the left, 3 on the right. So I'm going to make this, I'm going to double this so we're working with even numbers because now I've got 2 on the right, and I can just double this one to make it 4 on the left. Oh, I mean I have 2 plus 2 on the right, so that makes 4. And hydrogen's still balanced now, so that's fantastic. Here we've got another combustion reaction. So let's see what goes on here. Oh, no, it is a combustion reaction. It's just got some oxygens in it. I'm going to leave oxygen till the end again because oxygen's the only element that appears by itself there. So 6 hydrogens, sorry, oh my gosh, I'm starting to lose the plot a bit, aren't I? 6 carbons on the left-hand side, so I need 6 on the right-hand side. I've got 12 hydrogens on the left-hand side, so I want 12 on the right-hand side, so I need 6 waters. Count the oxygens. On the right-hand side, I have 12 oxygens here, plus 6 there, so I've got 18 in total. So on the left-hand side, I've got 6 here, so I need 12 more. And this is already doubled, so I need 6 there to get 18 on both sides. Okay, next one. I'm going to start with just aluminium because it's the first one, and it is balanced. I'm going to leave oxygen till last because it's in everything. I'm just going to hope that by balancing the other things, oxygen will end up just sort of getting balanced in the process. So I've got 3 carbons on the left-hand side, and I've got 3 on the right-hand side because I've got 3 lots of carbon trioxide, and in each carbon trioxide there's 1 carbon. Okay, so 3 of those. So I'm going to pop a 3 out the front of CO2. Now aluminium still looks fine. Now we cross our fingers and count oxygen. Alright, so oxygen on the left-hand side, I've got 3 here, plus 6 here is 9, and here I've got 3 lots of 3, which is also 9, so that is balanced, so we're happy with that. Alright, this one, it looks again really messy. I'm going to balance aluminium first. I want to because it's the only metal, and that's really the only reason I have. I'm not going to choose oxygen, I suppose, because it's in everything. I could choose sulfur, but I just like aluminium better. So aluminium, I've got 1 on the left and I've got 2 on the right. So let's triple that. Now I'm going to do sulfur because it's the other one that only appears twice. And here I've got 1 sulfur, and here I've got 3 sulfurs. So I'm going to need 3 of those. Now let's check something else. Let's just go with hydrogen. So here I've got 6 hydrogens plus 6 here because there's 3 lots of that and 2 lots of the whole thing. So 6 and 6 is 12 hydrogens there. So if I want 12 hydrogens here, I need to put 6 out the front there. Now I've crossed my fingers and count the oxygens. So 3 lots of 4 oxygens is 12 there, plus 2 lots of 3 oxygens is 6 there, so 18. And on this side, I've got 4 lots of 3 is 12, plus 6 is 18. So oxygen is balanced, which is nice. Next one doesn't look too horrible. Let's say we started with sulfur. Then I've got 8 here, so I'm going to chuck an 8 there. Now let's look at oxygen. 2 there, and on the other side I've got 8 lots of 3, which is what, 24? Is that right? It is, isn't it? 24. Yeah, it's a 24. Yes. Okay. So it's going to double it because of the 2 there, so I need half of 24, so that's 12. Good, that was fun. Next, another combustion reaction. All right, so for this one, carbon first, 18 on the left-hand side, so 18 on the right-hand side. I've got 38 hydrogens, so I need half of that over here. What's half of 38? It's going to be 15 plus 4 is 19. Now I need the oxygens. So on the right-hand side, I've got a calculator here. I've got 18 lots of 2 oxygens, which is 36, plus 19. I'm absolutely sure I can do that in my head. It's like 55, right? Yes. 55 oxygens. That's a lot. This is a bit of a crazy one. And then I need half of 55 here. 55 divided by 2, of course, is 27.5. And of course, we hate decimals. So let's double everything. 2, 55, 36. What's double 19? 38. Okay, that's gross. 3 to go, we're nearly done. Okay, so next one, again, I'm going to choose calcium because it's the metal, but looking at it, actually calcium's already balanced, so that's all good. So what else will I choose? I'm going to leave hydrogen, I'm going to leave oxygen because they're sort of everywhere. I'm going to look at nitrogen. So on the right-hand side, I've got 6. I do not have 6. I've got 2 nitrogens, 1 there, and that whole thing's doubled, so 2 nitrogens. And here I've got 1 nitrogen, so let's double that. Calcium still balanced. Let's count hydrogen. 2 hydrogens here plus 2 hydrogens there makes for 4 hydrogens. On this side I've only got 2, so let's double that, so I've got 4 hydrogens on both sides. Let's check oxygen now, and it should just work. We're in trouble if it doesn't. 6 oxygens there plus 2 oxygens there makes 8. And on this side, I've got 6 oxygens there plus 2 oxygens there makes 8 also. So that's 8 on both sides. So that's beautiful. Nearly done. How good. All right, this one I'm going to leave chromium and copper till last because they both appear by themselves. I'm going to do nitrogen first. 2 nitrogens on this side because the whole thing is times by 2. 3 nitrogens on this side because the whole thing is times by 3. So I'm going to put a 3 there and a 2 there. So I now have 6 nitrogens on both sides. Now I'm going to check the oxygens. I've got 6 oxygens in there. Times by 3 is 18. Here I've got 3 lots of 3 is 9 oxygens there. Times by 2 is 18. So oxygen is balanced. So now let's do the metals. 3 coppers here, so 3 there. 2 chromiums there, so 2 there. Lucky last. Sodium looks balanced, so let's do hydrogen. Got 2 on the left-hand side and 3 on the right-hand side. I don't like I've got 1 there because it's like you're giving me an odd number because of that. So I'm going to double that. So I've got 4 on the right-hand side because then I can easily just double that. So I've got 4 on the left-hand side. Now I'm going to check sodium again. 2 sodiums on the right-hand side now. So I need 2 on the left-hand side. And I've got 2 oxygens on the left and 2 oxygens on the right. So that's balanced. So that is all the questions. I'm sorry that this has been my most boring video to date. But there you go. Thanks for watching.